Thank you for introduction and good morning, everybody. I will show us a said about renewable energy potential. I will highlight a few of our studied done in recent years. Quite many slides. I try to be quite quick. So I start with renewable energy production potential, mainly wind and solar, which has been discussed already today. Then something about what this kind of power to X production means and needs. Also about the CO2 capture and CO2 capture potential. A little bit about the infrastructure, which has been also discussed a lot today and which is essential part, and then a bit about the modeling needs. So we have been doing this kind of map exercises about the full potential of wind power in different regions. Here are some examples from southeast Finland, which is currently underutilized due to issues with the border and military restrictions and radar issues, but we have been nevertheless looking at what could be the potential. And our approach is that we look at map solutions and look the potential areas from wind atlas, and then restrict buildings, roads, rails, and other things that cannot be utilized, and then look what will be the maximum potential. And of course, every wind turbine is not built, but then to look some a realistic base scenario that we, for example, for this southeast part, we have selected roughly 50% of those potential parks, which already gives quite significant amounts of energy and wind power. So we are talking about almost 60 terawatt hours of wind power production potential, mainly here in North Carolina. Earlier we did same kind of study for this Botnian Bay area, looking both northern Sweden and northern Finland, and here, as is well known, we have a very good areas and the annual production potential. I guess existing may be already a bit smaller than actual today. It is building very quickly with more capacity, but we estimated that long-term capacity in here, talking of energy production, would be more than 100 terawatt hours energy, and thinking of current energy use in Finland, electricity about 80 terawatt hours. We are talking about significant amounts. Same kind of study was done for offshore wind power potential in Åland region, and they're also thinking of converting it to hydrogen, either offshore or then transmitting electricity to mainland and then converting that electricity to hydrogen in later phase. So these are few examples of the, of course there are many other places in Finland, and actual potential is much more. We have been also looking at solar power potential, especially in southeast Finland. We've been looking at this kind of large scale potential and mainly looking at peatlands, existing peat production area, mainly for that reason that they are easily available from map solutions, and they are areas that has been already, there is some kind of road infra and but there is of course other than peat production areas, this kind of wastelands that could be utilized. But we look the peat production area and also some rooftop areas in this southeast and east Finland, and with 50% utilization rate, so 50% of peat production areas covered with solar panels would lead to some 7 terawatt-hours, and rooftops also with, let's say, only one half of the roof and one half of that covered with the panels would give some additional 3 terawatt-hours per annum. So solar power potential in amount of energy is also significant. It is about 10% from wind power potential, or even a little bit more in this area. And they are complementing quite nicely with wind power, so often when it is not so windy, the solar and vice versa. Of course, the problem with seasonal storage exists. This is roughly the same figure Simo was already showing earlier today about this total wind power potential in Finland based on this grid gas grid connection requests, showing huge increase potential, but of course also challenges in permitting and actual manufacturing and other things. So maybe not taking as a real development pathway, but to show that the potential is huge. So from renewable energy production potential, we have it up to several hundred terawatt-hours of wind and some 10% of that solar. Going to power to X production, we have been talking a lot about hydrogen, but hydrogen is often not the main product used. We need other kind of chemicals, hydrocarbons, or fuels, chemicals, materials, plastics, and there we come to this power to X production. And there we need carbon dioxide if we produce hydrocarbons. Of course, ammonia is one route for utilizing nitrogen and hydrogen, but looking at hydrocarbon production, we have good opportunities from our industrial plants, and we can expect even biomass burning for energy is probably reduced, but still we have chemical pulp industry and other forestry industries remaining, which produces high amounts of biological CO2. And here is some example of looking at Finnish pulp mills only. We have currently some 13 chemical pulp mills existing, and they produce more than 19 megatons of biogenic CO2 each year. And converting that to, for example, methane would produce more than 100 terawatt-hours of methane, which is 4 times of current natural gas consumption of Finland. And it would require, of course, significant amount of energy to produce the hydrogen, mainly for this power to X production. Similar exercises for southeast Finland, only looking at what we have pulp mills there, and we have some methanol production potential. So with only in southeast Finland we could produce some 8 megatons of methanol from those biological CO2 emissions, and well, it is very difficult to currently say some actual price for example, green methanol. Estimations vary very highly, and anyways, we are talking about a huge market and maybe in the future even more. And as an energy content is 8 megatons of methanol would be roughly the current energy use of road traffic today. Of course, it is not meaning that methanol should be used only for road traffic, but just to have a figure in mind of what is the value, and it would require some 80 terawatt hours of electricity to produce this hydrogen. Similar values can be shown for this Botnia Bay area. We have these detailed reports available, so I don't go to details in this short time. And infrastructure has been discussed today a lot. There is a question, we don't know correct answers. What will be transported? Where the hydrogen will be produced? Shall we transport electricity, hydrogen, carbon dioxide, or perhaps then this chemicals, liquid or gaseous fuels, and so on. And different storages, as Sami described earlier, that in each part we can have storages for the different commodities, and those technologies are what are under development, and we should also know what are the performance and cost data, and to have a rigid and resilient system. We have been studying, for example, this North Carolina. We don't have existing 400 kilovolt lines, so how much it would cost to build new lines or several parallel lines would be needed to utilize this old wind power from North Carolina here, where it would be utilized, or is it better to use it there? And then also for this Åland area and also some hydrogen transport scenarios for different areas have been done. Finally, I would like to, let's say, advertise. We have been starting at NUT to do this kind of energy modeling initiative to answer some of these questions. So we should have cooperation with different organizations to share data and share this understanding of this energy system change and transition, and this kind of initiative has been started. We have been starting to think what kind of modeling blocks are needed for energy markets transition to future and so on, and I think we will tell you more about this later, but wish to have all research organizations in this same task to get more understanding of how we should make a Finnish society as efficiently that we can use this our great energy resources and material resources in the future. Here are links to some of these reports we have been producing. Thank you.